And a last one on this, because it's important, okay? This one is important. Marginal stability and convergence, how do they connect? Because there's one mistake that is done very often that I want you to do not do. That is, let's go first of all to this table. I hope that you get that all the combinations can happen. Are we together that all the combinations can happen? In general, everything can happen. There's something that, let me write it here. Let's rewrite together. No, we do. You know what? We do it by table. Marginal stability. Definition of marginal stability. For every what? Is it okay like this? Written this way? No, why? Because I need to have strictly bigger than 0. Okay? And then here, what do I write? That exists. True? Exists. What? Delta. This one, is it okay? No, it has to be like this. Such that what happens? If I have my initial condition where? In a ball that is epsilon ball or delta ball? Delta ball, if I start from initial conditions that you choose, then what happens? Yt, no, it's marginal stability. Yt is inside B epsilon. True? This is marginal. Convergence. I write it here. It's just a moment. Let me do something. It's going to be helping. Got it. Marginal convergence. How do we write? For every delta, or there exists a delta? No. There exists a delta bigger than 0 such that y0 inside my delta, sorry, b delta, then implies yt converges to the equilibrium. Watch out. There must exist at least one. It's not for any delta. Let's make a practical example. You're going to see it. This one, I should add it to the slides. I'm going to add it to the slides. Y dot, let's make it here. Y dot, an ODE that looks like this one. This one, this equilibrium here, is it marginally stable? Yes, no, I do not know. Discuss. So how would you say, people? How would you say? How would you answer? Let's see. Tell me, I do not know if you do not know. Everybody says convergent. Somebody says do not convergent. The epsilon ball. How many dimensions does the epsilon ball have? One. We have a one-dimensional ODE. An epsilon ball is something that contains. True? And it's a segment. Are we together? Perfect. If I am the boss and I draw this epsilon ball, which delta ball would you choose? Would this delta ball be okay? Yes. Would this delta ball be okay? No. Cannot be bigger. Perfect. If as a boss I choose this delta ball, would this delta ball be okay? No, why? Because starting here makes me escape. True? Would this delta ball be okay, the smaller one? Yes, true. And if as a boss I choose this epsilon ball, delete this one is okay, true, as a delta. Together? Are we together, people? Marginal is stable. Is this one convergent? Yes, no, I do not know. What would you say, people? What would you say? Yes, no, or do not know? Yes, why? Because if I take this delta here, my trajectories will converge for any point that I start. This delta here, would it be okay? No. This delta here, would it be okay? Yes, but it's not the biggest one. Which one would be the biggest? And I'm using the round parentheses because can I take in also the equilibria here? No, because if I take in that equilibria, I'm not going to have convergence. True? So I need to get the minimum strict minimum. Minimum. Strict inequality. Are we together? And it's enough that I'm able to find one delta such that this happens. Okay? Let's go back here. Here we have exists. Here we have for every epsilon that exists. Okay? This one and this one, do they need to be the same? No. Let me show you an example. This is a classical misconception, confusing those two deltas. Those ones would be even better if at the exam you say this is delta convergence, and this is delta marginal stability. They are two different deltas. Let's make an example. Look at this example here. Y, of course, y dot, okay? This equilibrium here, is it convergent? Yes. What is the biggest delta convergence that I can take? This one, true? Together, are we together? That is the biggest delta convergence. So this one is the delta convergence max. Together? Perfect. If as a boss I tell you, are you able to confine in this epsilon? Which delta marginal stability would you choose? You would choose something for which? Well, in this side, you can choose something that is here. Maybe I'm not symmetrical, but it's okay. Here, you cannot take something farther than here because otherwise it goes out of epsilon. You see it? If I was taking this delta here, I would go outside epsilon. So I have to take this delta marginal stability maximum, that depends on epsilon. True, because if I change epsilon, that one changes. You get the point? This is a situation for which this one is smaller than this one. Draw a situation for which the vice versa. This one is smaller than this one. Go. Go. Invent. You got to invent an ODE, single dimensional, and a case for epsilon such that delta marginal stability is going to be smaller than delta convergence. Extremely easy. This is extremely easy. And of course, I'm taking max delta C. Right? You can invent an ODE. How do you feel? Take a first order LTI. Take a first order LTI and try out. No, actually, I'm saying a stupid thingy. No, it doesn't work. Actually, I've got to think also. So delta C is infinity. And if I take epsilon, yeah. People, first order ODE. Are we together? People, look at me, look at me, look at me. This is y dot is equal to alpha y with alpha negative. True? Delta convergence maximum is going to be what? Plus infinity. True? Because everything is going to be convergent. This is going to be called, in nonlinear systems, you are going to do characterizations that are much better characterization. Globally asymptotically stable equilibrium, a gas equilibrium, because this one is the whole basin. Together. If I take a certain epsilon, the delta ms has to be maximum that epsilon. You see? How much are we together, people? Please, are you following? So, main point that I want to say, these and these are two different animals. Okay? And typically, if I want to have simultaneous marginal stability and convergence, I will have to choose which one? The maximum of the two or the minimum of the two? The minimum of the two, because they have to guarantee both properties. Are we together?
Perfect. This thing that you said us to let us see that, for example, the delta of the marginal stability could be smaller than delta of the convergence. Actually, doesn't depend on the system, but depends on the boss's choice. So also the previously so could be like satisfy what you said by choosing just a smaller.
Indeed. Actually, here, if the choice of the boss would have been this one, I would have had the same situation. Okay? Excellent, excellent. Now, I say it's the same as before. Are we together that convergence and marginal stability two different things? Are we together that the deltas are two different things? Perfect. Then I would say that if there are no other questions, no, and then we stop this